Okay, today we're looking at lesson 1.1 for Algebra 1. The practice that we have, our practice for examples or our practice with examples sheet. Our goals are to evaluate variable expressions. Remember what variables are? They're just letters or symbols that take place of numbers or that take the place of values. We'll actually define all that very shortly. And we're going to write a variable expression to model a real life situation. The first thing is the definition of a variable. It's given to you right there. It says a variable is a letter. It's usually a letter, and like we said, typically we use the letter X, but you could use Y. You can use any letter you want. If you are modeling a situation where you need to remember two different things, like let's say you're talking about fries as one, if you're trying to find a difference, and this is a very, very common problem, like on the ACT and stuff like that. You're talking about like fries and drinks, and you're not using X or Y. Don't say fries or Z or T or something like that. Use F. Do yourself a favor. Use F for fries. Use D for drinks. But again, the most common thing you use is X, and that's the reason why you use that dot instead of that X to represent multiplication. But it represents one or more numbers being a set of numbers when you're talking about something being greater than or less than. Um, the numbers themselves are the value of the variable. Notice the bold print. That's the values of the variable. Those are the numbers. A variable expression. Now, here's the difference that students have a problem with a lot of times. They have the difference in what's an expression and what's an equation. It's a very, very easy thing to determine the difference. An expression doesn't have an equal sign. As simple as that. So 2 plus x is an expression. 2 plus x, and more specifically in this case, it's a variable expression. If I say equals 3, now it becomes a variable equation because I just created an equation. Then it says replacing each variable in an expression by a number is called evaluating the expression. For example, x equals 2. 2 plus x. Evaluating the expression means you're taking this value of 2, you're plugging it right there, and saying 2 plus, now it becomes 2 instead of x. That's called evaluating the expression. Evaluating it and then simplifying it. And then writing the units of each variable in a real life problem is called unit analysis. What that means, if we say we're 5 miles away from something, instead of just writing 5, you're putting 5 miles. If you say somebody weighs 130 pounds, you're not saying 130, you're saying 130 pounds. If you're curious as to why LBS is pounds, it has to do with the fact that this horoscope sign, a lot of y'all have seen it as a horoscope sign. It's just, it looks like this. Y'all seen a picture like this before? It's like two scales. That's a horoscope sign, two scales with Libra. A lot of times we'll talk about balancing the equation. You'll see that phrase or that term, balancing the equation. That means if you subtract 2 on one side, you got to make sure to subtract 2 on the other side, or it's going to get heavier on one side or the other. But this is the symbol for Libra when you're talking about horoscopes. That's Libra, and that's where pounds comes from, LBS, Libras. I was always curious as to why, just in case you ever want. You can't never say I didn't teach you anything. That's the reason. So let's take a look at the first example. It says evaluate the expression when y's value equals 3. So that means in place of y, all we're doing is substituting in the value 3. So instead of saying y minus 5, now it's saying 3 minus 5. And this is a very common mistake students make when they have to go from a positive number to a negative number. Think of a number line and think of where it is in relation to 0. This one says start at y's value, in this case is 3. So at 1, 2, 3. You don't need to draw a number line, but this is the way you need to think, especially when you're going from one side of 0 to the other side. Start at 3. It says minus 5. Minus 5, you know minus means to go to the left. So go 5 times. 1, 2, 3, and then we got to go 1, 2 more times, and that's how we get to the value negative 2 in that place. The other one says 12y. Since two things are right next to each other, that means 12 times y, or 12 times, notice we'll just put in parentheses, means to multiply by 3. And 12 times 3 is, in fact, 36. Okay, in the margin or on the back, copy down and work these 4 problems. Take about 1 minute to do so. Okay, for the first one, letter A says 4 times y. We're evaluating these expressions when y's value is 3. So all we're doing is substituting it in. 4 times 3, we know 4 times 3 is simply the number 12. For the letter B, it says 12 divided by y, or 12 divided, again, we're plugging in the number 3 in place of y. 12 divided by 3 is 4. For C, y plus 8, and again, in place of y, we're plugging in 3 plus 8. We know it's 11. And then 18 minus y minus 3, when we plug it in, 18 minus 3 is the number 15. Very, very simple. All 4 operations: multiplication, division, addition, and subtraction. Let's take a look at the exercises that go with example number 1. We'll only look at number 1. You'll do the rest on your own. Some of y'all already started. 8 plus x when x's value is 6. All we're doing is plugging in the number 6 in place of x. It becomes 8 plus 6. And when you put 8 and 6 together, you get 14. Notice we did not create our own equal sign. It's a very common mistake. Even I see adults and other teachers that are not math teachers doing that. They'll do something like this: 8 plus 6 equals, they'll add their own equal sign. Don't do that. It's not going to make a huge deal right now, but later on, it'll set you up to make a mistake. Don't create equal signs. Just simplify them as you go. Okay, let's jump to example number 2. It says evaluating a real life expression. It says you deposit $300 in the bank. That pays an annual interest rate of 2.5%. Just to give y'all a heads up, um, banks, the formula they use is never this simple. They use what's called compound interest. It's much more intricate than this, but we're talking about simple interest, which is PRT. Notice all 3 of those letters are next to each other. You may or may not have seen this in junior high before. PRT, it just means principal times rate times time. Your principal is what you go ahead and put in to the bank. Your principal is $300. That goes in place of P. So to evaluate that is to plug in $300, and you can see right below it in place of P. Then it says an annual interest rate. The R is next. The rate is 2.5%. Now, anytime you multiply by a percentage like 2.5%, you have to change something about this. You can never multiply straight like that. You have to make one change, and that one change is, since it says percentage, it means per hundred. You have to move the decimal over 1 time, 2 times, and you get 0.025. And you can see right here in place of R, it says 0.025. So we have 300 times 0.025. And then the last one says, how much simple interest will you earn after 2 years? And T is the last variable that we are evaluating or substituting it in. You can see 2 in place of there. When you multiply all 3 of those values together, 300 times 0.025 times 2, you get $15, which means after 2 years, you earned $15. Again, you're doing the same thing with a real life expression. Here is an extra example. Okay, and I know on this sheet right here, it does not show perimeter things, but we did see it in our belt work. So please copy this one down on the back as well. Take about 1 minute. Just draw it real quick. You don't have to be real fancy with it. Just draw it and put the numbers. About 1 minute. Okay, let's take a look at this one. It says find the perimeter of A plus B plus C of the triangle, and then it says the dimensions are in centimeters. So we can use unit analysis in this case, and we could say the perimeter equals A plus B plus C. Okay, and that's what was given to you. All we're doing is plugging in or substituting in the values. In place of A, we're substituting in 1. Plus, let's fill those in. In place of B, we're substituting in or we're plugging in 1.75. You'll hear me say the word or the phrase plugging in place of substituting all the time. Don't freak out if you hear me say that. And in place of C, 2.25. So the rest of it says perimeter equals. Notice we went from having 4 variables, P, A, B, and C, to now we only have 1, P. So we can solve for perimeter. In this case, they're all centimeters. So perimeter equals 1 plus 1.75 is 2.75, plus 2.25 is going to be 5 centimeters for the perimeter of that rectangle. Okay, and then you can come back to doing these in a minute. The last one, example number 3, says if you are driving at a constant speed of 65 miles per hour, how long will it take you to drive 325 miles? Again, you just plug in what you got. Miles per hour. Notice that has 2 different units. Anytime you're talking about 2 different units, more often than not, that's going to be talking about your rate. So in place of the rate, you're plugging in 65 miles per hour. Time equals distance over rate. We'll talk about this more as we go. But in place of rate, we're plugging in the number 65. In place of time, it says, well, how long will it be? It says how long. So that's going to have to be a variable. That's anytime it says how long or it does not give you a value, you have to represent it with a variable. In this case, we use t so we don't get confused. And then the last one, it says to travel a distance or 325 miles. Miles is a distance measurement. So in place of D, we're going to plug in 325. So what that gives you is 325 miles divided by 65 miles per hour. So when you divide miles by miles, they cancel out to make the unit rate simply the amount of time, which in this case the time is 5 hours to travel 325 miles. Here's one more example. Copy this one down. Take about 1 more minute. We'll talk about this one, and the rest you'll finish for homework. Okay, let's finish this one up before we run out of time. It says find the average speed. They throw you a little bit of a curveball right there. Average speed you can call rate. So rate equals distance over time. We have a distance of 89 miles. So 89 over, we have a time they gave us of 2 hours. So we're looking for the average speed. When you divide 89 by 2, we know that's an odd number. We get 44.5 miles per hour. So your rate in this case is 44.5 miles per hour.